So what I wanted to make you aware about is a third sort of attempt, in a sense, for running a virtual machine. We do have a virtual desktop infrastructure that's just been initialized, and you guys are the guinea pigs. Congratulations. Patients or beta testers. So what it is essentially you're going to get, instead of having to run an extra, a virtual machine or a virtual box, VM player or whatever on your personal computer, you exchange it for doing a remote desktop. So the faster your network is, lower latency, the better that particular experience is going to be. So if you have trouble at home for your home network of getting a fast connection to the university, I recommend running the virtual machine on your computer. That'll be less painful. And so on the where you get to it on is essentially on the resource page, right? So you're going to be able to see that there's an option there for the virtual desktop. And so when you're on this screen here, there is a guide essentially that's going to give you step-by-step for doing it on Windows. I don't know if they have a Mac one. For Mac users, you may want to do this approach just because I don't want everyone to buy software just to make the homework assignment run. But essentially, you're going to click on this link. Now, you have to be logged into the campus, right? One of the things that I was informed about is that my Podium computer is not in EU Rome. And so, if you don't, you're not going to get to this page, right? It's going to time out because the firewall is going to prevent you from getting to it. So you have to set up the Cisco AnyConnect if you haven't done that already. To log yourself into the campus network. Once you've done that, and you click on the link, then you'll be able to get to the page. Now, there are two different passwords you're going to use. This first one's your normal engineering password that you have, right? So I'm just going to log in here and show you from my end. Of course, I don't want to do it. Now, that's interesting. I didn't print off the little error screen that I had before. Maybe that's coming up. So we have two, in a sense, virtual machines that we have going on. That's a generic Windows 11. So yes, if you want to use this, but all the stuff's going to basically be over here on Kali Linux, right? So I think with Action, it's shut down, reboot. Okay, so I just want to click on Start. We'll shut one down. No. Okay, let's just do it and say yes. All right, so this is where I'm going to get a little confused in some sense because I have to set this up for the thing. But we're going to be basically using the RDP, and so I didn't have this set up. Let me see. I'm going to leave. I'm not going to go into this right now to the fullest extent, but let me just tell you what's happening next, essentially. In this case, on this computer, I would use the Windows Remote Desktop to take the RDP address, particularly the IP, the IP port and port numbers. Those are the ones I want to use to log into my remote desktop. Now, when you use those things and you log in, once you get to the VM log screen for Kali, right, Kali's login screen, the username is student and the password is student. Terribly secure, we know. So I will have more details. Like I said, there's the guide that has it on there, and I'm going to try to today, tomorrow, update this in the sense for giving you options on using VDI if you want to use that instead of running your own virtual machine on your computer. The homework will still be the same. In other words, whether you're on the VM or you're on the virtual desktop, I need the screenshots essentially that you're on Kali Linux. In other words, you successfully got in through one of the mechanisms. And I really, like I say, if you have network issues, I recommend the virtual machine by itself. If you have an awesome connection, I recommend using the VDI, because that way it's less load on your computer. That needs to say that whichever way you go, all the homework assignments are going to work. Because I designed them to run on Kali Linux. And if I do say that you need anything in the homeworks, then I believe I give you instructions on what to do. So it's a little bit of a multi-step way to get this done, but I think you'll find it easy. Let's see if it'll just. Is that going to do anything for me? No. Okay. Never mind. But that's the new thing on there. Like say if you, let me see, where is it? Is it CSE-support at, or was it support? What's the email address for IT support?
support@csc.msstate.edu.
Oh yeah. Okay. So if you run into any trouble with getting access in through to VDI, then send an email to this computer science tech support people being support@csc.msstate.edu. Okay. I will be in my office tomorrow from 1 to 3 if there's any problems with that, but so I can help you on that. Let's see if I have anything else on my cover. Let's see. Yeah. Okay. Any other life questions, whatever, something, before I go on? Okay. Okay. So what we're trying to do in this class really is to get, I'm going to say exposure, I guess hopefully that's the right word to use, to be, into what's kind of going on when we are attempting to do reverse engineering. Really, in a way, reverse engineering can be described of as how does something work, right? We can do it on a physical device in the sense of I could take apart a bicycle, understand how all the gearings work together, for example, on it, right? But in the case of what we're doing here, it can be useful as a part of penetration testing, as into you're trying to find a weakness, for example, maybe in a library or something that's been you have access to. But for what we're doing this, with Wireshark, right, is we're looking at what can we gain from what's passing across the network, right? And this is just this particular assignment of what we're doing for one of those with Wireshark. It's just a very basic one. You've already got Wireshark experience, I believe, from some of your other classes. And so why am I talking about that, right? A lot of the malware that's out nowadays, especially the ones that are trying to be like, what is it? Get a client on the machines, but then you're connecting to some command and control network saying, what should I be doing next, right? And so the malware, the first piece that may be on the machine doesn't have sort of attack payload on it. It may go off to the server and say, what should I be running now, or something like that, right? So communication is going to be happening in some capacity between those little clients, in the sense that they're hidden on someone's machine, and the command and control network, right? And so we want to be able to look at what's going on in the network communication, right? You're not going to find necessarily a communication link that says secret network for hackers. It's going to probably be hidden in some capacity, right? Maybe they just pass around numbers, right? As into that number translates to something on the end of the system, right? You're not going to see like attack payload 1 or attack payload 2, right? Think of it as you're a detective. You're trying to figure out what's going on in this program or on the network, right? And they're trying to hide. I guess you call it a nerdy form of hide and seek when you really think about it, right? But for what we're trying to do here, like say, is we're what is it? So like I said, people can hide it. Like for example, think about DNS in the sense. Are there fields in DNS that are not normally used? And would you normally stop DNS traffic from going through the firewall? Maybe the answer is no, it won't necessarily do that, right? But for example, if I'm trying to do a simple command and control and I don't care necessarily if someone knows the number I'm passing across because they don't know what that number means, right? Then I could probably use DNS request to quote, the command and control server has a DNS server that's responding, but it's not really a DNS server. It's just reading the packet and just sending it back a normal DNS response, right? People are going to try to hide stuff in there. That's your job, is to figure out what's going on. So one of the things that you learned, if I have some people that take both classes, and I kind of like one after the other with them. And so we just talked about processes, in a sense, in operating system, right? So we want to think a little bit about how does an operating system load our application in here, right? So we're going to start with a few sort of general phrases that we're going to use throughout this semester, right? Right, so when we talk, when we load an application, right, it reads the file itself that's on your computer, right? That file is follows a very specific format that tells it essentially what operating system it's meant for. It'll tell you stuff of like what libraries it needs, because you're using shared libraries, and therefore those symbols need to be provided to you and such, right? Malware programs, not malware, antivirus or opening something in Ghidra is static. In other words, we're not running the application, right? And there is some concern about even trying to run things in sort of like a VirtualBox sandbox, virtual sandbox essentially, so that you're trying to, So we're going to we're going to read those instructions that exist in the file, right? Because when the operating system looks at your file format, it tells it, okay, here are my code instructions, here's my read-only data, here's the libraries that I need, right? And so when you run Ghidra and you open up that same file, right, you're going to see the assembly instructions and information in there. We're not actually executing the program. So that's what we call static analysis, right? Now, if you want to and try to, you can run something, right? Remember when I was talking about hiding things for communication, people are also going to try to hide what their instructions are doing. We'll get a little bit on to it later about things that people attempt to do to hide their program from us observing it. Right? There's anti-debugging techniques that people use. So we can use a debugger to try to run the application. Like I say, if somebody does their homework right, they'll have things to say like, is a debugger present? If it is, I will terminate. Or there's other things that you can look for. You don't have to necessarily look for the one function, the one system call, excuse me. You can basically look for some other features. I don't remember exactly all of them, right? Problem with, at least for me, that I'm always concerned about is I don't know necessarily if that application is attempting to change. If it's running on a machine, that's not necessarily a big deal. If it's changing the firmware on my devices, then I'm a little concerned, right? Because, people when they're doing these kinds of things, they're using penetration testing to find a vulnerability, and then once they find a vulnerability, they make an exploit that gets them on the system, right? They want to then escalate their privileges so that they can basically become root or the administrator on the machine. Right? And so they're going to try to hide their activities from you. Right? There are various mechanisms that they can do with that, right? But if we really wanted to, we could try to observe what's going on in the system, right? So with binary reverse engineering, right? We're taking what exists in the file, right? The fully compiled code for your project, right? Gets ultimately turned into some intermediate representation. Ultimately, gets returned into assembly language for the architecture and question, and finally, the linker basically pulls it all together and creates you an executable that works, right, for what you're doing, right? So you start it in programming language, use the compiler, it produces the binary, right? We're trying to do the backwards. We're trying to decompile, right? We're trying to basically take it from the low-level assembly instructions to high-level code to say what's going on there, right? The way to kind of think about this in one way is if you had very simplistic instructions, step forward, turn left, and I forget what other one. Let's say those two, right? If I keep doing a bunch of these enough, I will get to my house, right? So if you looked at all those things, just in the file itself, left turns, straight left. Let's say that's all my processor understood. It'd be hard to understand what's going on. But when I put all those together, right, then I see how to get to my house, right? So that's kind of what we're doing here. Is we're trying to figure out what are those assembly instructions telling us. Is it really loading an effective address, or is it doing math? Are we doing adds and subtracts because we're trying to calculate probabilities or something, right? We have to dig through this stuff to figure out what's going on, right? So one of the things that can be useful, but also, again, they're going to try to hide these things from you, are strings that are stored inside the file, right? Sometimes there are, in your read-only data, there might be information that's in there. For example, of maybe particular strings that are supposed to be put out to the console, for example, saying, what is today's current temperature? And once you enter in the temperature, for example, it converts it from Fahrenheit to Celsius, right? So we want to try to see what is in this file. This is one of those static analysis things where we can go. It says, okay, I might have, perhaps in there passwords and such that has been found in some sense when people reverse engineered the ransomware stuff. And because in some ways, it's like, whatever your quote encryption algorithm is, if someone does quote pay you the money and then you quote unlock the system, then the key has to be somewhere there, right, for you to be able to unlock the system, right? So that's another good curious question. Is it really in the binary, or is it another one of these command and control things or something? I don't know. All right. There might be, definitely we're going to find on your, I guess you'd say your honest programs, the ones that are not malware, you're going to see the libraries that you depend upon, what functions you're going to need from those things, right? And sometimes you might have stuff in there. For example, you can encode strings in base 64 encoding, or you could use AES encryption or compression or whatever in there, right, to try to hide that kind of information from somebody who is trying to just simply dump out those strings and say, okay, what's going on here, right? Deception and secrecy is what the malware people are trying to do, and you're trying to figure out what you can find, right? So it's always one of these games of you build a lock, they build a lockpick, you build a better lock, they build a better lockpick, and it just keeps going, right? So, in some ways, since things get developed here, right, the first way in which people were encoding strings with ASCII, essentially the American standard, essentially this, I think it goes up to, was it 256 characters or something like that? And that's enough to essentially cover American English, capital, lowercase letters, numbers, special characters, and so on, right? But if you look at the other languages in the world, sometimes they have more characters than 256. So how do we handle that situation, right? So sometimes in your file, you're going to find strings that are in the ASCII encoding. And UTF-8, if it's only 1 byte, it's the same. Essentially, you're going to find UTF-8, the first so many characters of it are going to basically be the same as the ASCII table. But Unicode essentially is using these variable-sized values to basically encode a character in some language, right? And so most of the time with, what is it? Java, I believe, is always using UTF-16, I think. I forget which one was doing what. But you'll find that more in use nowadays inside of stuff, whether it's on Windows, even Linux, because that's not necessarily platform specific, right? And so the idea, for example, is we can represent in hexadecimal what we want for characters, right? And so like I said, with some of these ones, some languages there are more than just, I guess it would be 52 normal characters or 62 if you want to include numbers, right? No spaces and whatever, right? To represent strings. So like I say, when we're looking at Unicode strings, right, they're going to be longer than this potentially, or this could arguably be UTF-8, for example, right? Yeah, UTF-8 is backwards compatible, as I'm saying here. And you're going to see that more often as used because, like I say, you can support a lot more languages with that particular style. And this is just a different way of looking at it, that when I'm opening the file, and I'm looking at what's going on there, and I simply use a hex editor, for example, I'll see 67, 65, and all stuff. And so this base hexadecimal value, so it's from 0 to 9, A through F for each position. And that's going to translate into essentially a lookup table that says, okay, that's a G, E, K, and S, right? And so I give this as a different way in the sense of how you can store the same same character using the various types of Unicode, right? UTF-32 is always going to use 4 bytes doing it. So from purely, if you're looking for a compactness point of view, that's probably not the best one to use for English, right? Because we could be satisfied simply with UTF-8 or ASCII, right? And you can see here the omega symbol essentially is, it's not in the ASCII tables. I don't think so. If anyone's bored and wants to look up ASCII tables, tell me if the omega one's actually in there. But I say we're going to have to find strings that are in there, and like I say, most likely what you're going to see is they'll be encoded perhaps in UTF-8, but they might be scrambled into something else. It's to eventually understand what's going on in a program. If you give enough time, money, and people, anything can be broken. Well, I can certainly understand what it's doing. Let's say I'm just about to say if you can break AES encryption, we're really screwed. I'm just saying that we can certainly understand what's going on here, right? So I didn't put a picture for this. I probably should for my other class, right? Right inside the OS loader, right? Inside the file, excuse me. We have stuff in the program headers and the various section headers that tell us how big those sections are going to be, right? If you remember from operating systems, right? We're going to load the instructions into our stack, frame stuff, right? Where we have the code and then the data and then we have heap and then there's space between that and the stack, right? For each process, right? Each process is going to have a stack that we're messing with, right? And so the loader is going to first see that, okay, this indeed is, let's say, a Linux program. It starts with the letters ELF and I think the null character, I think, after that. There's 4 bytes in there that they use as the signature. I think Java uses Cafe Babe or something because they were starting work on the program language in a coffee shop. You can just use whatever. But, so we also have to, when we're looking at stuff, if we're relying on shared libraries, that could be another indication of what's possibly going on in your program, right? But you don't want to do that, right, if you're the malicious person. You don't want to give any hints of like, hey, this was meant to run on, let's say, Windows 10 or something like this, right? With what shared libraries that you're pulling in, right? You want to hide those things. But a normal application will have symbols that are going to be available from those shared libraries, right? Windows does dynamically linked libraries, DLLs. Linux does shared libraries, usually ending in .so. When it comes to static, though, static will be added into the binary, so you won't find it looking for something like that, right? So that is another technique to kind of hide out what's going on, is that if I exclude how many things that I'm inlining everything that's in there, then hopefully those strings don't show up in the file itself, right? So we're adding those shared libraries in there to our image space, so we say like, okay, when your program gets loaded, you're loaded anywhere in memory, right? And a certain offset to the shared library file are the symbols you're looking for, right? So it's taking care of all those things, right? And then once we're done, right, okay, we don't need the file anymore, right? We're going to basically turn the program loose and start running, right? So it's kind of important to understand what is in the files and what is it asking for in external libraries as such when you're trying to understand what a particular program is doing, right? Because one of the things you have to be aware of, at least, right, is I can change the extension on Windows from, let's say, .zip to .pdf. If all I'm doing is checking for the extension in my firewall, my security rules or whatever, saying you're not allowed to send PDFs out of the network on email, right? I'll miss those things, right? I'll miss the fact, I miss the zips. Say I'm not supposed to send zips. That's the other thing to say. If I didn't want to send zips, change it to PDF, and can I send it that way? Or can I change it from zip to PIZ? You know, silly things like that, right? But ultimately, at the end, it's the file content itself is what we want to check, because, you know, does it start with the right things that say, like, for example, Windows. Believe it or not, there's actually still a DOS program that's in every Windows portal executable file. And it simply just says, I cannot run this application on DOS. If you'd actually have a machine that you can still do that on. It's basically has enough space in that it says, okay, where is the real header that I need to be looking at? So the first one says MZ, because I believe that's someone's initials. And it says at certain, I think it's byte 40 in hexadecimal. It tells it where to go to find the Windows portable executable header itself. Right? So there's, you know, we can't just look at extensions alone to say it's Windows, or Linux or Mac or whatever, right? And so, so what I was trying to do here, and was kind of show in a sense, let's see, there's where something is really going to exist in virtual memory, and then there's real memory, and essentially what we're getting from the file, right? And just to show that we're, just because it's over here at a certain offset doesn't mean it's going to be at the same offset in there. So it, I should probably put the other one in there. Let's see. Yeah, so I'm going to skip that. Right. So with Wireshark, why I'm just trying to play around with that for just one assignment, right, is communication nowadays is for malicious programs are you're connecting to somebody. You're connecting to some control network. So, you know, how many compromised machines are there, right? I need to have some sort of communication between the application itself and the home network, so to speak, right? And so we want to be able to look at capturing this kind of stuff. So in this, you know, I'm kind of curious in this sense, I haven't looked up into this, but like with the use of AI, ChatGPT, or any one of those large language models or something, because they're great on classifying, right? Can I train one of those in a sense to identify malicious traffic in the network? And maybe what I want to do in that thing is, for example, is to train it on expected, normal, good traffic. Everything else can be considered, you know, would be malicious, right? If I have an unknown bucket or something for what's going on, right? So we want to be able to use this program for, like I say, capturing various kinds of traffic, you know, since it's going on there, right? You know, because if you have a thermostat that's on there, you know, it's on your house and stuff like that, and you're looking at the traffic. I haven't done this yet, but I'm curious. If it's in my house and I own it, then I think I can avoid the warranty. You know, what would I expect it to do for communication? But if it's doing 480 traffic or something, or pulling stuff down or something, or maybe send something out, but then I also see 422 traffic, you know, SSH, what the heck? We should be needing to log in remotely to my thing, right? My thermostat should, if it wants to connect to the mothership and I set it up that way, then it's like, okay, I expect I'm going to find certain traffic that it sends out, right? Is there anything else going on, right? Because compromising Internet of Things is a very real thing nowadays in a sense that's going on, right? Now, when it comes to secure protocols and such, if you have the certificate, I think, or something, you can decrypt the SSL. But most of the stuff that we're going to be messing with is not encrypted. We're just trying to mess with what's going on, right? So that's an interesting question for the first homework assignment. Because are we allowed to capture on this network, right? If I'm malicious, I don't care, right? I'm capturing, end of subject. But for us, we're trying to do the right thing. So it's like, you've got to basically ensure that you can capture stuff on that network, right? Because there might be laws that are preventing you from doing such things. I mean, it seems a bit unfair that a hacker gets to get away with anything, but we're having to follow by the rules. And, well, I'm trying to stay out of prison. I don't know about you, right? So we need to have sufficient privileges, right, to be running Wireshark, essentially. Now, this is where I don't know with VDI, right? If you're running stuff on your stuff and you have a virtual machine, you'd be able to do the homework no problem. But I don't think you're going to be able to do the homework assignment on VDI, which I'm going to have to figure out what I'm going to do in that situation. Because if you want to set your network card into, what is it, anonymous mode or something like that, basically you're listening for everything that's going on in the network, right? You need to be able to do that with root or be a part of the Wireshark group on your network, which is allowed to, you set it up on your computer to basically allow a user to do Wireshark capturing essentially on the network itself, right? And so, what we want to do is we want to target, in a sense. We're looking for perhaps things that are coming to from a particular machine, right? To understand what is the normal traffic, right? So, like some of the printers are certain printer queues and stuff like that, that are remote, and therefore you might expect traffic to be going over certain port numbers, right? And if you know more about your network and stuff like that, you know what IPs to be looking for on that, right? And so if I'm trying to capture everything that's going to and from my printers, like I say, and I see traffic that doesn't make sense, right? Then I might have an indication that someone is looking on doing something on my network, right? We need to have essentially those captured packet information so that, what is it? I'm thinking about an analyst later. So on some of the stuff you're messing with, you may want to restrict to an extent, right? Promiscuous mode, that's the one I was trying to look at. I don't know why we chose that word. If someone is promiscuous, it doesn't mean a good thing. Yeah? But we want, like say, do we have permission to be on the network, right? We have sufficient privileges to be in promiscuous mode. We want to test, right? We want to figure out what we want to be looking at, right? Because you can capture everything. And maybe that's possible in a sense, but you know, maybe you want to like restrict some things, basically saying I want to look for only Ethernet traffic or point-to-point protocol, PPP, that's going on in there, right? And so if you just want to restrict, for example, to 172.18.54, right, that's where we use the host command. Or we can say that we want to look for any traffic that's coming from that range of numbers, right? Are you familiar with what this slash notation means? If anyone doesn't know, I don't mind going, just you can raise your hand. Okay. So basically what we're saying is that number to the right of the slash is saying the number of bits that from left to some point are fixed. So in other words, we're saying they're effectively, it's always going to start with 192, it's always going to be followed by 168, it's going to be followed by 0, but then after that it could be anything. Now we're talking IP version 4, so there's only 256 possible values after that point. Everything from 0 to 255, right? So it's saying a set just like shorthand, so I don't have to type in there all 256 possible numbers. I can just pass that in there because I'm a lazy computer scientist and I want to be efficient with my time. And so we can, like say, we restrict to port 80 or typically IP traffic that's in there, right? Or if we want to look for certain things that are going on, right? So these filtering enable us to restrict, in a sense, so we can focus on particular parts once we find something that's interesting to us, right? So if you're trying to be sneaky and underneath the radar, right, I want to hide in the noise, essentially. I don't want to spike out and show that there's, you know, what happens where something went from, 50 bytes per second to 200 gigs per second or something, just make it a ludicrous number for the point, right? So the people that are writing these kinds of programs are going to be trying to be hidden in storage or hidden in usage, right? So let's see here. This one was very short. I think I was trying to show difference. Let me see here. Yes, I think, yeah, I've got to get caught up, I think. So what we've kind of talked about today is more for the Wireshark assignment. Now, this is the one that, because I'm asking, we're trying to ask stuff to capture it on the loopback device. Loopback for internet stuff essentially is like localhost. There's no place like 127.0.0.1. Place like your humor, right? So in this particular one here, there's a program that's going to be running, program 1 and program 2. And so I made it to only use the loopback so that hopefully we don't have to worry too much about people screaming, because you're trying to capture a package, and we don't want you to be capturing stuff that's coming off the network. I want you to stay isolated within the little virtual environment that we're running. And so the way I have some of these assignments set up is that you're going to be using essentially Canvas's quiz feature as a tutorial. It should step you through step by step about what I'm looking for you to do on this particular assignment. So you're trying to answer some of the questions that exist in there, and I believe it's one of those questions that's kind of asking about what's going on, right? So, this first one, for example, is saying, does program 1 not produce any traffic? Well, you have to be able to run that thing and see what's happening, right? So I found this to be a very good way of walking you through it one question at a time so you don't get confused by it all. And it should be sort of step by step in this. And so, but it's, it's a little simple assignment, and I'm not trying to make a bunch of busy work, right? Let's see, so that's kind of what we're using this stuff here today on that. John the Ripper and Lab 1. Eventually, we're going to learn more about what's going on in the different file formats, because that's where we can potentially find some useful information in there, right? Whether it's the strings that are going on, perhaps even trying to identify in there from entropy and stuff like that. Do you find sort of compressed fields in there, essentially, right? Because one of the things that I don't like about file formats is I can store, let's say, 1K on the executable file itself as it's stored on the system. But then I can tell you in, essentially to the operating system, yes, this particular section that's in the file, it's only 1K in size, really takes up 12 megs. Why does a 1K thing need 12 megs on a program, right? Shouldn't all my stuff just be there in the file? So if it's 12 megs of memory, it's 12 megs of data, right? That could be an indication that somebody has compression going on. I mean, it's overly dramatic on the sizes, but you get the idea that things can be hidden in there, right? And so we're having to look at all these different pieces of information, statically, at least initially, to figure out what's kind of going on, right? If you want to, let's see here, as a precursor, you can actually do this for a living, reverse engineering programs. I mean, antivirus companies are going to be interested. Certain federal agencies, now that they're put a moratorium on hiring federal employees. I don't know how this is going to look for job stuff. Sorry, it's just the times that we're in, right? But there are certain agencies that are interested in that kind of thing themselves, right? No such agency or NSA, I think the CIA might be interested in stuff like that, but or FBI, more importantly. And so you can find work in this kind of field, right? But reverse engineering is only going to be part of your repertoire with what you're doing. Any questions on today's thing or so? I feel like when I ask those questions, is there any questions? And I do want to get questions. I feel like it's a staring contest. Who's gonna break first? If you don't have any, that's fine. Or you don't want. That's the reason why. Also, I have the exit tickets in my emails. Because maybe you don't want to put your hand up in class. That's fine. You can come talk to me later, or you send me an email, or or come to office hours or something, right? So. Let's see. Like I say, I would double check that you can, if you're going to use the VDI route, that you have the ability to do Cisco AnyConnect essentially from home if you want to do that. I think this will be a lot easier, but you guys are testing it out for the first time in the sense of how much load can this system handle in a sense for what we're doing. So I guess any concerns or questions, or what do you think? What are we going to do anything naughty in this class in a sense? No, we're not. But I'm always looking at ways to potentially improve this, And that's another thing. Just because I get to be called Dr. Torrey doesn't mean I know everything there is to know. If you find a resource or program or something along that line, send it to me, seriously. Maybe it's useful for us in this class and I'll include it in a lecture, right? I'm willing to, take any information you guys provide, right? Because this is one of the things that I would say is we do a lot of homework in here by ourselves, right? Unusual in the sense that we're doing it because I need to judge how much you understand, right? But if we were really doing this for reverse engineering on something, it's a team of people, at least two, right? Because there are some things that we can do, and I've played around a little bit with the AI stuff, that I need to mess around a little bit more with, like trying to put heavily optimized programs and having AI potentially reverse engineer. You can do some things, don't use it on your homework. Seriously, I'm trying to judge your knowledge, not the technology that you're using. Yes, we will be using most likely that something in the future. I do see that happening. But when it comes to what we're doing here in the class, we're going to do it manual the first time around. So let me know if you have any problems with getting Gehedra up and running. It should be installed already in Kali. Or you can't get your VM running or the VDI is giving you trouble. This class is short today on this particular subject. I don't want to waste your time and repeat ad nauseum what I just said. So if you don't have any questions, stay warm. Don't get hypothermia. And I will see you on Thursday. Otherwise, you can come up and talk to me now.